This is the pipe you're going to be analyzing. Well, you don't need, it's just like to get a visual. The inlet is face 27 on the CSV files. It goes in through the inlet and then it comes out of those two outlets. And then the Y direction is up in this case. Since it's kind of like lying along the Z axis, the Z, oh, you don't know how to import it? Wait, yeah, let me just go over that a little clearer. I think it's better to share my entire window actually. So I hope this is what you see first. You're gonna click on the home tab over here. You're gonna go to import data. You're gonna find the file. For me, it's in desktop under here. You're gonna click on the file that you want to import. Click open. It's gonna open this extra window over here. Then you just want to click import selection on the top right. And then after you get this message, it means it was imported, and then you can use it in your data from now on. Okay, another visualization of the velocity distribution across one of the cross sections of the pipe. We don't need to know that. That's just that's what we have, but we do not know in what direction, basically. Okay, here's the syntax for the data analysis import. When you're analyzing a data set in MATLAB, you need to tell it where it lives, what row and column. So the syntax for this is variable equals data set, rows, comma, title of column. For us, we are going to use all of the rows because that's how the data is formatted, and the title of each of the title of each of the columns in the CSV file. So that's the syntax for that. Next slide, Abe. Okay. Yeah. So in plotting 3D data, again, you need to tell it where it lives. But figure creates a new figure so that you can plot multiple in one iteration. And plot 3 allows you to plot 3 variable data. So if you recall back to last lesson with the simulation and projectile motion, we were using plot. Now we're going to use plot 3 to plot 3 variable data. Yeah, and then grid on for the grid. So again, I'll do this with you guys right now. I'll share my entire window for that. Okay, so first, since I have the files downloaded, I'm first going to say that time is equal to, since across all 3 files, the time is constant, I'm just going to use UX for the time. Import all the rows, and let's start with phase 3. Then I'm going to import the UX velocity for phase 3. Again, UXV1 is just the variable name I'm picking for that. UX phase 3. Oh yeah, don't forget the semicolons, otherwise it's gonna print like 1,000 values to your screen. Oh, also, to use this for your project, there's another version of MATLAB. You can get like the license stuff for well, we'll show you guys later, but you can get like the unlimited version on a 30-day free trial. So whenever you're doing data analysis for your project, you can use that. Because the online version only lets you use the files within MATLAB itself. So that's kind of an issue. Okay, now, like I said, we're going to create a figure. Then we're going to plot 3. So, oh yeah, don't forget it's X, Y, Z. So first we're going to plot time, because on the slides, if you could see first, we're going to plot UX versus UI. Uh, oh, UX V1. And then since it's not a function, I don't really need to end it. And Copilot is going to tell you to label them. You can, it's not really necessary. This is more to get like a visualization. But if you want, like, sure, if you want to like maybe stick it on your trifold or something, it's useful. So yeah. Or it's time for us actually. Oh yeah, and always use single quotes. That's another thing for this kind of stuff for the labels. And then I'm going to turn the grid on. Now, when I go to the editor and I run it, first I got to save this. Let's just call it data. Oh, wrong folder. Shoot. Opened it up somewhere. I don't know. I probably forgot something somewhere. Uh, oh shoot. Time is the time in seconds. Sorry. And I'm just gonna. Hopefully this works. Not bad. Um, Let me try to figure out what was wrong. In the meantime, just maybe try to think about how you would maybe plot the others. Let's say if I asked you to plot time versus UX and UI, how would you do that? Or UX and UZ, how would you do that? So if I go to my editor and I click run here, I'm gonna get this 3D plot. So this is the best way to look at it for the time. Right. Okay. So as time goes on, this is how UX and UZ react. Or wait, is this UZ? Oh, yeah, this is I think I ran the wrong file. Oh no, this is UI. My bad. But yeah, same thing. Same plot. You get this graph. And as you can see, as time goes on in the X direction, it's not really it's going back and forth a lot. So the pipe flow is kind of oscillatory at the beginning, and then it kind of stabilizes because it doesn't move in the X direction anymore after that. So you can see that if I map it onto here, kind of, and then in the Y direction, if I look at how it changes with Y, I can see that it's the Y actually stabilizes over time. Sorry, I interchanged them. And the X is kind of erratic over time. It's not really a function. It just keeps going back and forth over time. And it doesn't really stay concrete. So that's why a 3D plot is so useful. And I think for your last activity, I'd like you guys to try to figure out the syntax for plotting UY versus UZ and UX versus UZ. And I'll go over that in 5 minutes. just gonna plot, copy this because this is very useful. Copy this over here. I'm gonna plot time again, UY this time, and then UZ here. Right on. And then when I go into the editor and run it, I get two figures. I get one which is UX versus UI, and I didn't change the thing to reflect that it changed to UZ, but the plot is way different than the UX UI plot. This is UZ, and this is not UX UI, and this is UZ. Let me just change the code to reflect that really quickly. This is UI, this is UZ. So yeah, and if I wanted to see how each of these react to time, I can turn it over here. So as you can see, the velocity in the Z direction kind of levels off, kind of plateaus, and it becomes constant. So the velocity exiting the pipe over phase 3 would kind of start, it would basically kind of accelerate, but the acceleration would slow down because it looks kind of like a square root curve, right? And then if I move it over to this face, or here to this face, this is UZ versus UI. This is less commonly used, but it shows you how UY changes as UZ changes. So if you were only restricted to 2 dimensions and you wanted to see how it would evolve over time, you can actually make an animation where this gets traced over, this basically gets traced over time and use that to draw conclusions. And then on a 3D plot, that's especially useful because you have no idea where it starts, or it's really hard to tell. So if you make an animation, you can actually plot 4 dimensions, the fourth dimension being time. And then the last face I want to show you guys here is time versus, or this should be probably like over the top view. Yeah, well, yeah, this, but yeah, perfect. This shows you how UI is evolving over time. The time axis is kind of inverted, don't worry about that, but so again, it levels off and it becomes 0 over time, but at the beginning it's very erratic, so it's not moving up and down much. Or no, it's not moving, I think for UI it was left and right. It's not moving left and right towards the end, but it is moving a lot at the beginning. And so you can use that in your data for your ACSEF project whenever you do one. So I think with that, that concludes our ACSEF, our event. If you have any questions, you can stay back. Otherwise, you guys are free to go.